Apache Airflow is an open source orchestration tool that helps you programmatically create workflows in Python. That helps you run, create, schedule, monitor and manage data engineering pipelines. No more needing to mess around with cron jobs. Hello, my name is Ricardo Sueiras, and if you're currently building or managing data pipelines, then I think you're going to be interested in this session. Let me share what I'm going to be covering. First, I'm going to share the problem space that we see companies as they try and scale their data pipelines. Then I'm going to introduce Apache Airflow, talk about its architecture and provide some of the key concepts that you need to know about. Then we're going to come out of slides and we're going to build our first workflow in Apache Airflow and then start to build a very simple sample data pipeline. And then finally, I'm going to share some resources, including all the code of the demos that I'm going to be showing today. So first of all, let's look at the actual problem space. And if you take a typical data pipeline, you will have a number of steps that you need to do. You will need to collect some data typically, and it might reside in lots of different locations, both internal and external. You might need to clean, filter that data based on your user's needs. We might need to combine that data, filter out, and then store that in maybe a data lake or our data warehouse. And we need to be able to do that in a way that's secure so that only those authorized to access that data can have access to that data. Now, it was very common for all of these tasks to be managed independently and discreetly. And it was also very common for you to use tools such as cron in order to schedule those tasks. Now, one of the challenges of this approach is that as you use more and more data and as your use of data scales, it becomes harder to manage and make sure that all those pieces work reliably. So what was really needed was a way to orchestrate all the different steps or tasks that we do typically to manage our data pipelines. And many organizations have begun to start using tooling, commercial tools to help them with those efforts. And it was in 2014 that the data engineering team in Airbnb open sourced the tool that they had created to manage their own data pipelines. In 2019, Apache Airflow became a top-level Apache project, and it has been growing in interest and popularity ever since. So let me cover a few key terms and concepts to help you understand what Apache Airflow is and how it can help you with your data pipelines. So the grouping together of various tasks, as I mentioned, is what we called a workflow. And within Apache Airflow, workflows are defined as directed acyclic graphs or DAGs. Now these DAGs are collections of tasks that you need in order to achieve your outcome. So in the earlier step, all those different indiscrete tasks combined together would be, for example, a workflow or DAG. In Apache Airflow, our workflow or DAG is represented by some Python code. And within this file, we use Python code to first determine the characteristics of our workflow or DAG. And each DAG has a unique identifier called a DAG ID. And we'll look at more of that in a bit. Now, a unit of work within our workflow, also in Python code, is added to this DAG file. And like our workflow, each of those tasks has a unique ID as well. We call that the task ID. Now, in order for tasks to be able to complete what they need to do and to simplify the life of our data engineers, we use operators. Operators determine what work gets executed, and you can think of operators as templates for doing a task. You provide some information and the operator takes care of the undifferentiated heavy lifting. Apache Airflow uses a number of different kinds of operators in order to simplify how you work with your external systems. Sensors are a special type of operator that are designed to do exactly one thing: wait for something to happen. For example, there's a sensor for waiting for a file to appear in an S3 bucket. A hook is a high-level interface to an external platform that allows you to quickly and easily connect and talk to that system without having to worry about the kind of low-level coding to do that. And within hooks, we use connections to define the credentials and the connection details. Again, this makes it easier for you as a data engineer just to focus on the tasks and not have to worry about all those low-level things you need to configure. Apache Airflow has many different kinds of operators, and these are augmented by third-party, vendor, as well as the open source communities that are contributing to the Apache Airflow project. And here you can see just some of the operators that currently are available. And if we look at all of them, you'll see that most of the systems you will typically need to interact with as you create your data pipelines are represented. A collection of tasks is what makes up a workflow, and each task has a relationship and dependencies with other nodes or tasks in the graph. And this is where the term directed acyclic graph comes from and describes the relationship between those nodes. Now, before we can run and orchestrate these tasks, we need to know how to deploy them into Apache Airflow. And Apache Airflow reads the contents of a special folder called the DAGs directory. And once you copy your DAG, your workflow file, and any associated files that you need with that, Apache Airflow will read them. And if your tasks have dependencies, for example, Python import statements, you can actually load these through a standard requirements.txt file as well. So now we've got our DAGs and Apache Airflow can see them. How do we actually schedule and get these executed efficiently? Or rather, how does Apache Airflow do that? So the Apache Airflow architecture uses a dedicated scheduler which understands and submits tasks that need to be executed. The executor handles the running of those tasks. Now, these will typically be done on dedicated worker nodes where the tasks within your DAG will execute. And it's important to note you shouldn't make assumptions that all the tasks will run on all the same nodes. The scheduler will schedule in parallel if you have multiple worker nodes, for example. The Apache Airflow scheduler is very powerful and it allows you to very precisely control how you schedule your workflows. When we create our DAG file initially in the very first file I showed you, we defined within the properties of the DAG what schedule that we want to use using the schedule interval parameter. Now we can leave this at none, which means it will just be triggered on demand, or we can specify a cron-like syntax. So anyone familiar with cron, as you can see, I provided some examples at the bottom there. Now, understanding scheduling in Apache Airflow is really important. So again, if we look at the DAG properties here, we have a value called start date, and this is used as the starting point for when Apache Airflow scheduler will actually plan how many tasks need to be scheduled and executed. Now, if this value is in the past, Airflow will work out how many times from the moment this workflow is enabled now to that moment in the past, and figure out how many slots it needs to create in order to execute the workflow and all the tasks within that workflow. So I provided a very simple example there to explain that at the bottom. Now you can, if you want, disable that parameter using the catch-up equals false. And that's normally pretty useful when you're first developing and testing your workflows. Now, the metadata database is where Apache Airflow stores all the information about the tasks, the workflows that have been processed by the executor and scheduler. And we're going to come to see that a bit later on. It's also used by the web server and the UI, which we're going to come to in a minute, to store all the different values that we might want to use within our workflow, such as variables and the connection details I mentioned that are used by the hook operators. And it has a very nice UI which allows you to enter that information, and that's all stored and encrypted in the metadata database, which leads us back to the UI, which we're going to see in a minute when we start our demo. It has a very nice UI that makes it very easy to see our workflows and our graphs, allows us to interact with them, trigger them on demand if needed, allows us to view the output and state of those, allows us to see failing tasks. It also allows us to do things, admin tasks, such as set variables, set connection details that some of our operators might need. So let's come out of slides and into code. I'm going to start off by showing you how to quickly install Apache Airflow. We're going to use a project called Moa Local Runner to do that, and we'll get Apache Airflow running on our local machine and build our first workflow or DAG. Then we're going to build something a little bit more representative of what you might be doing, which is building a very simple data pipeline, grabbing some data from the internet, downloading it into an S3 bucket, processing it a few times, and then storing it in our data lake and data warehouse. We're going to do that in a managed service of Apache Airflow. AWS released this a few years ago. It's called Managed Workflows for Apache Airflow, or MOA for short. And what we're going to build is this architecture. So we're going to take those files from the internet, we're going to process them, store them in S3, and then we're going to also put them into our data warehouse. So that's what we're going to build. So let's come out slides and take a look at it. So the first thing we're going to do is see how we can install Apache Airflow. If we go to the Apache Airflow website, which you can get at airflow.apache.org, we can see that if we click on documentation and Apache Airflow, we can click on the installation link and we get access to a very complex and comprehensive list of different ways we can install Apache Airflow. Now, I've got a repo which I'm going to be sharing the link later on, which provides another way you can install Apache Airflow using a project that we created at AWS that's called AWS Moi Local Runner, and it runs a bunch of containers which you can run locally as long as you've got Docker and Docker Compose. That brings up an instance of Apache Airflow that you can use for local development, testing, that kind of thing. So I'm going to use that. So I've got it ready to go here. So I'm going to start it now. This is going to take only a few seconds to do because I've already run it, which means it's downloaded all the needed containers. The first time you run this, it might take maybe 5 minutes whilst it builds the image first. Okay, so whilst it's doing that, we're going to talk about creating our first workflow. Now, I've actually got a sample workflow which we're going to work on, and this workflow is going to have 3 tasks. It's going to create a file, it's going to rename a file, and it's going to delete a file. We're going to see how we do that in our workflow. So as mentioned, a workflow, a DAG, is just a Python file, and as such we need some various Python libraries in order to create our workflow. Some of these are related directly to the constructs needed within Apache Airflow, so some of these ones. But we also need an operator. Okay, as mentioned before, an operator makes it easy to work with various systems. In this instance, we're going to use the bash operator, and the bash operator makes it super easy to run and execute bash commands. So this is our import statement. Every workflow then has some default arguments that you need to set. I'm not going to talk too much about these, but you can change these if you want. Then we have our workflow unique DAG ID. You can give it a name. In this instance, what I'm doing is I'm giving it the file name. So we should see our DAG workflow called bash_copy_file. And then we actually create an instance of the DAG object. So we pass in the unique DAG ID. We give it those default arguments. We give it a description. And then, as I mentioned earlier, we specify a schedule and a start date. So here I'm specifying none, which means it's going to not run a schedule. It's only going to be triggered on demand. And I can also specify some tags, which can be useful to help it stand out when we have lots and lots of workflows. We then actually take a look at the bash operators themselves. So here we can see that we've got a task, we've got a task ID, which is unique, and it's using the bash operator. Every operator has its own parameters. In this instance, the bash operator takes one value, one command, which is bash_command, and it's a string of all the commands you want to run. So here I'm specifying using some variables I've encoded in this Python file to create a directory, to create a file, move a file, and then delete a file. Now, once we've got those tasks, in order to build the relationship, the graph, we do that using this annotation here, the greater than sign. So the first task is followed by the second task, is followed by the third task. So this is a standard bash file. We can see now that the Moi local run is running. So if we go to a browser and we go here and refresh, we see that we have no current workflows. And as mentioned, we have a special directory called the DAGs directory, whereby we can copy. So this is the DAGs directory. We can see it's currently empty. And so let's copy that file we were working on here. So we can now see our DAGs folder in Apache Airflow has got one file. So we should see one workflow appear, and voila, we now have our workflow up and running. Now, when you're doing this the first time, you won't see any of these values set. The reason why it's coming up here is because I've run this a few times before, and so those values have run. Now, when you create a workflow and it starts in Apache Airflow, initially it will actually be in stopped or up or paused state. To enable a workflow, so it will run either on demand or via schedule, you need to enable it, unpause it. So we're going to do that there. So if we go into this, we can actually view the code of our workflow by clicking on the code. So we can see here that all that code we created is here. So let's now trigger this, and we can do this a number of ways. We can click here and trigger it, and when we trigger it, we get the option to enter some configuration information, which is optional but super useful if you want to create kind of templated workflows which are driven by parameters you specify when you trigger them. In this instance, we're not doing that, and then we're going to trigger it, and we can see that this is running, but it's actually failed. So let's have a look at why it's failed. By clicking on the task, and we can see that we can see a whole bunch of information around it. So by looking at the log, we can see that this is actually run, and we cannot create this directory because it already exists. Okay, so this is a problem with our workflow. So what we're going to do is we're going to go back to our workflow. We're going to change this so that it works on a different folder, save it, and then we're going to copy back the new workflow. And what we should see is when we go back to the code, we should hopefully see the new value. And not quite. Sometimes it takes a few seconds before that kicks in. Unless I've done something wrong. There we go. We've got a new value there. So now we've done this. If we go to our graph view, what we can do is, rather than re-trigger the workflow, we can actually clear, and this will clear the error and re-trigger this failed step task. And when we do that, we can refresh, and hopefully it works, and it then completes the rest of them. So we can now see that. When we look at the logs, we can see that we've created it in this new folder here. So all good. Now, as I mentioned earlier, the Apache Airflow UI allows us to do things such as define variables. So here, for example, I can create variables. So rather than hard code them in my workflow, I can specify them within a variable here within the UI, and then that way it keeps my code unchanged. I can just drive and change how it works by defining the variable. So let's change some of these work directories. Let's call it /temp variable demo, and we'll call these ones desktop text. We'll call this one source.txt. Okay, and then what we need to do is we need to change our code. So what we're going to do here is we're going to import another Apache Airflow library called variable, which allows us to access those variables within the Airflow. And so we'll comment these out. And I've already got the code here. So effectively, we're just now keeping the variables, but we're using variable.get, which will use the key, which is here, and then pass in the value. So let's save this and copy the DAG back in. And again, we're going to need to wait a few seconds. I think it's normally 5. I've set this up to 5 seconds. So let's wait, see if that works. Again, we check on the code, and hopefully we can see now this is using variables. So if we trigger this, we should see those new values. So let's refresh that, and we can see hopefully it's now worked. And if we click on the status of these logs, we can actually see that it's using the new variables. So here we go, temp variable demo. So we can see how we've now improved our workflow by using some of the features of Apache Airflow, i.e. the variables. Okay, now we've done a very basic workflow, and we've shown you some code that kind of looks at some of the concepts we talked about earlier. How do we actually build a data pipeline? So we're going to go back into Visual Studio, and I've got another workflow here, which is a much more complicated one, and actually has a number of different other kinds of operators. So again, just to remind us what this is going to be doing, if we look at the architecture. So we're going to be using a managed service for Apache Airflow, which is called Moi. And what this is going to do is it's actually going to go down and it's going to copy some files. In this instance, we're going to be using the movie, what's it called? The movie lens, group lens. It's a bunch of files that contains films, ratings, that kind of thing. And we're going to grab that and we're going to put it onto an S3 bucket. Then we're going to store that using Athena and process it. We're then going to clean it up. In this instance, what we're going to do is we're actually going to just remove all instances of the letter E in all those films. And then we're going to actually put it into our data warehouse. Okay. Now, typically when we're doing this in production, we will have a CI/CD workflow whereby we commit our workflow and a pipeline will run it through some tests, again typically using the WAR local runner. I'm not going to do it in this demo using that. However, there is a blog post and I'll share resources to that later on that shows you how you can set that up in various different configurations. So if we go back into the actual code itself, let's actually have a look at what it looks like. So again, we're importing a bunch of Python libraries and using different operators. So we're using this time a Python operator. We're using an HTTP sensor because we need to download some files from the web. We're going to be using the Athena operator because we want to use Athena to do some of the processing of the data. And because we want to check for files in S3 buckets, we're using the S3 key sensor. Then we have those default args again. Our ID, like the previous one, we're just going to use the file name. So we should see the DAG called movie lens -redshift. And then we're specifying a bunch of variables. Now here, what I'm doing is I'm using, again, Apache Airflow's ability to store these rather than hard code them in the actual workflow themselves. And there's a bunch of variables such as the file we're getting, the S3 bucket name, as well as the Redshift cluster. Now, if I take a look at the code, all this stuff, okay, the Redshift cluster, you can build for yourself. I've created a CDK app that allows you to build everything you need. And there's a blog post which you can actually view here that shares and walks you through the whole process of doing that. So it should be hopefully super easy to do that. Then we've got the actual scripts that we're going to, the SQL scripts that we're going to run on Athena. And then the specific tasks. So for example, downloading a file, cleaning up a file. Now, if we look actually how these might typically be pre-Apache Airflow, you might have had scripts like this, for example. So this is the download script. This is the cleanup script. You might have had these running manually and then just scheduling them via cron. Okay, so I'm just taking these standard tasks that we might have done manually and incorporating them into my workflow, but this time using one of the Airflow operators. So this is a Python operator to create a task. And then as we scroll down, we see that we're creating our actual DAG itself with all those different operators. So here, for example, we've got the S3 key sensor operator, we've got the Python operator, and then we've got those Athena operators. And you can see here that they're taking different values. So the bash one just took one command, but the S3 key sensor takes a whole bunch of other things that you need to make sure you add. With the Python operator, it has a single value, which is Python callable, and it's referring to a piece of a function within this code, which needs to appear before we do this. So that's why if we go up here and we go to the download, we can see this is the download function, which is referred to in that Python operator. And then at the end of this, we've actually then got the relationship between the nodes. Now this is much more complicated than the one before. Here we can see that we've got lots of nodes pointing to other nodes. And we'll see actually what that looks like by going to the console. So here I've already uploaded it into the Apache Airflow on Moi. And if we look at the graph view of this workflow, oh, I need to log in. And we can see if we look at this and look at the graph view, this one's a much more complicated graph. So here, for example, we're checking for that file. Once that file has been copied, we're processing individual parts of that file. We're splitting it out from tags, ratings, a movie. We're joining that up and creating a table in Athena, and then we're doing a cleanup, in this instance removing the letter E. Whilst that's happening, we're creating a table in Redshift, then we're then moving that data into Redshift. So if we trigger this, we should hopefully start to see this workflow going through all those different steps. It shouldn't take too long. I have run this before, as you saw previously. I ran it before. You can see now that the state of this is that where it's green, it's actually currently working. So it's finished creating the Redshift table, but it's still processing those files. What we can do is we can go into AWS and we can actually check to see the files. Where are they? Nope, not there. They're here. So we can see the files being created. So here is all the files that are actually currently being processed by those workers. So again, the Apache Airflow here is running a number of different worker nodes that are doing all that processing. So it's done all the copying and splitting out of files. It's now joining the information it wants into a single file. And then once it's done that, which shouldn't take too long, okay, and actually what we can, while we wait for that, we can see the logs information. We can actually see what's happened. We can see that it's actually outputting the information for that particular operator. So here it's the files it's copied. If we go to the Athena one, we can see that it's actually just showing that it's actually triggered the query and that it was successful. So we can see the status of that. And we can see now that basically it's completed. So what we've now should have is, if we go to Redshift, we should actually refresh this. We should now have, hopefully, oh, why it's not working? Our connect database, that's why. That's the one. Okay, refresh. And we can now see that we've got that. We can actually view the queries. Let's have a look, and hopefully, we can see actually straight away that the film Clueless has got the E missing, and also To Die For, that one actually is also missing. So we can see that actually that workflow has been successful, and we've gone all the way through this process from taking the source files. We can actually look at the original source files as well, just to show you that they actually did actually originally have the title correctly. So if we download this file, and let's look at this file. Let's have a look at the view terminal. Right, so let's go to downloads. Whoop. And cat movies. We'll see that there should be some E's there, so we can see heat. We can see that the source file did have a E, so the actual processing has been successful. So that's how we can use Apache Airflow to build workflows, breaking down the workflow into a number of different steps here, using different operators in order to interact with different services. In this instance, I've been interacting with AWS services. So I hope you found those demos useful and you now have a better understanding of Apache Airflow and how you can use it. If you want to hear more about how some of AWS customers are currently using Apache Airflow, then I've shared a link at the bottom here. We have a number of different blog posts that cover lots of different aspects of how many of our customers are using Apache Airflow, and they make very interesting reading if you're looking to understand a little bit more about how other people are using Apache Airflow. If you want to check out more resources, if you want to know more about moi, so that's managed workflows for Apache Airflow, then you can check out this link, or I urge you to check out the actual Apache Airflow project, which is the link on the right. Great resource, brilliant documentation, and you can also check out the project on GitHub as well. All the code that I used in the demo is available on this GitHub repository, so feel free to check it out and try it for yourself. And at AWS, we obsess over our customers, and getting feedback is key to that. So please, if you complete this survey, you'll get a copy of these slides, and we'll use that feedback in order to improve how we deliver these kinds of sessions in the future. So with that, thank you very much. If you want to talk about anything I've mentioned today or anything about open source, then feel free to reach out to me on either LinkedIn or Twitter. And with that, I want to thank you very much for your time, and I hope you enjoyed the rest of the sessions at DevCon.